Welcome to the Joe Watt podcast. I am Joao Vendramini from the Range Cattle Research and Education Center, and today our guest is Dr. Maria Silveira. Maria, thank you for being with us.
Thank you for inviting me.
Maria, can you please introduce yourself and tell us a little bit about you?
Yeah, sure. My name is Maria Silveira. I'm a soil scientist at the Range Cattle Research and Education Center in Ona. I've been in this position for about 12 years now, and I work primarily with beef cattle producers on issues related to soil fertility, water quality, and I also have partners with the environmental and regulatory agencies in the state.
And in the last Florida Cattlemen's meeting that we had, the quarterly meeting, we talked a little bit about the importance of biosolids as a source of fertilizer for grasslands. And I would like you please to define for us biosolids.
Sure, yeah. Some of you may have heard different terminology to refer to biosolids, but I want to just take a step back and clarify the difference. So when the domestic wastewater is treated, basically produces two byproducts. One is the effluent and one is the sewage sludge. When the sewage sludge undergoes further treatment, the material that can be land applied is called biosolids. So biosolids is the sewage sludge that went through additional treatment so it can be safely applied to land. And the term biosolids, was created in the early 90s by the wastewater treatment industry to differentiate this material that has a very high quality from the raw sludge that's being produced by these different municipalities. So there are different treatments that can generate biosolids: anaerobic digestion, dewatering, heat drying. So there are different ways to produce this material that we call biosolids.
And can you please tell us what are the different types of biosolids?
Sure. So biosolids in Florida, they are subject to federal, state, and in many cases local ordinances as well. So in Florida, most common types of biosolids we're going to find is Class B and Class AA. The Class B is the material that's most commonly land applied, and the major crops that receive biosolids application are citrus and pastures. Class AA, many times they are labeled and marketed as fertilizer. So if you look at the annual production of biosolids in Florida, we produce about 300,000 dry tons of biosolids material per year. About 2/3 of that, or roughly 200 dry tons, are land applied. So the difference between Class AA and Class B is the pathogen level. The Class AA contains pretty much non-detectable levels of pathogens, so there's no restriction. Class B, even though the biosolids are treated, there's still some small levels of pathogens. So it requires there's some additional requirements that are imposed when the land receives a Class B biosolids. For instance, for pastures, there's a 30-day grazing restriction for Class B biosolids. In terms of nutrient concentration, the Class AA or Class B doesn't cover the nutrient concentration. So you can have Class B materials that are equally, from the nutrition perspective, equally good as a Class AA material.
And why there is a public concern about the use of biosolids in grasslands?
The issues related to biosolids, like you said, a lot of those issues are perception, not necessarily real risks associated with human health, or even environmental impact. The first issue is odor. Depending on how the biosolids is being treated, odor is not very pleasant. So neighbors usually they are concerned about that potential odor that can come from a site that's been receiving biosolids. Even though there's no direct human impact, but there's that nuisance issue related to odor. And there's other things that they're no longer relevant for us. For instance, heavy metals. Heavy metals in the early 70s were a concern. In fact, my relationship with biosolids dates back from the 90s, I did my graduate work with biosolids, and my thesis, my PhD dissertation was on heavy metals in biosolids. But I'm originally from Brazil, and biosolids in Brazil contain high loads of heavy metals. In the United States, there's been a number of regulations that basically eliminated heavy metals in biosolids. So in the US, heavy metals in biosolids are no longer a concern, but the perception still remains. Other concerns are environmental impact, potential for biosolids to negatively affect water quality. And I want to remind again, there's land application of biosolids are subject to 3 levels of regulations. Like I said, federal, state, as well as local ordinances. So those regulations are intended to protect the environment. So there's a number of steps that need to be followed in order to apply biosolids. One of them is a nutrient management plan. So the amount and the frequency of biosolids application need to match the crop requirements, so to minimize any potential impact on the environment. One good thing about biosolids is, I'm not sure if you're going to ask me the benefits, but we talk about all the negative and the negative impact and perception, but there are multiple benefits. Biosolids contains important nutrients for plants, for instance, nitrogen, phosphorus, sulfur, micronutrients. Also contain considerable amount of organic matter, which is very important for our Florida soils. Our soils are very poor in organic matter, often exhibit a very limited nutrient and water holding capacity. So biosolids, again, we're talking about proper management of biosolids. They can improve soil quality because they add not only nutrients but also organic matter, which are very difficult to accumulate in Florida soils. And if it's following the proper regulation, is a safe and environmental safe as well as economic sound management practice.
And there was in the past some concerns about the soil pH when you add biosolids. What is the situation with the adding biosolids, the relationship with changing soil pH?
Well, some of the folks listening to this podcast may have actually experienced this issue. In the past, the most common way to treat sludge was by applying calcium carbonated materials or liming. So those biosolids were called lime stabilized biosolids. And the pH of those materials was very high, in the 11, 12 range. And if we remember that we were applying to pastures, most of the pastures that we grow, the forages that we grow in Florida, are warm season grass. They prefer a more acidic pH. So the recommended pH for most grasses are around 5.5. So over application of this calcium or lime stabilized material result in a dramatic increase in soil pH in many places in the state. I think the most common area was in Central Florida. And the issue was, well, forage cannot grow in the high pH. So when you exceed pH 7, Bahia grass, for instance, Bahia grass doesn't perform well in that high pH condition. Unfortunately, there's not an easy solution for that problem for these areas that received over application of lime stabilized material. There's not a soil amendment that can very quickly reduce the pH and bring the pH back to the desirable level. Calcium stabilization is no longer a common treatment process. There's still some facilities that do lime stabilization, but it's becoming more scarce because it's more difficult for the municipality to dispose the material. However, if it's properly applied, it contains that liming effect. So we're talking about over application, but let's say in a more ideal situation, if it's properly managed, biosolids, this type of biosolids can have a liming effect. So it can be positive in terms of bringing very acidic soil to the desirable pH conditions.
And if you have to summarize the current information that we have in the literature about biosolids application in Florida, can you give us a very brief overview of the effects of biosolids on Florida pastures?
Sure. There's been decades of research on biosolids in Florida. There's professors, colleagues that at UF that dedicated their entire career on biosolids. However, most of the previous studies, and if you look at the scientific literature, you're going to see that most of the studies were done in a very controlled situation. So we're talking about laboratory incubations, greenhouse studies, maybe some rainfall simulations. These are very important. It's very important information that these studies generated. However, translate that information to real field conditions can be often problematic. There has been very few field studies evaluating both the agronomic and the environmental impacts of biosolids application to Florida pastures. So that's what we're trying to address, that gap. Again, it's important to address both the impact on the production as well as water quality, which seems to be the most important one. And yeah, in terms of the publication, I know that many of you might not have access to that scientific literature, but there's been also some extension material, some education. We're trying to provide as much as information to maybe overcome that public perception. So, for instance, there's a number of IFAS publication. IFAS is an extension publication for University of Florida. There's one particular one that I wrote. It's the title is Utilization of Biosolids in Forage Production Systems in Florida. We discussed the different types of biosolids and regulations, etc. So there's quite a number of extension materials available out there.
And can you please describe what are the current research projects that you have with biosolids?
Sure. As I mentioned, I'm currently collaborating with a number of agencies. Florida Cattlemen Association was very generous. They've been funding a field study that's being conducted at ONA. It's a very well instrumented site. So we spend quite a bit of money on instrumentation. So we have lysimeters to monitor water quality. We have soil moisture sensors. We have gas chambers that we're periodically collecting gas samples. Let me think what else. We have pressure transducer to monitor the water table depth. And we're measuring, like I said, it's also important to measure the forage production. So we are currently on the third year of that study. Every year we apply different biosolids from different treatment facilities. And we're harvesting the plots. And I forgot to mention, these are Bahia grass pastures. And we monitor the forage responses, soil responses, as well as the environmental potential environmental impact on water quality and greenhouse gas emissions. So we have a PhD student that's fully dedicated to this project. As I said, we're in the third year of the study. That's another thing with field studies. There's so much climatic variability from one year to another. We have to monitor these responses for a number of years to make a more reasonable conclusion. Another study, also involved collaborating with the Water Management District, St. John's River Water Management District. We run a number of rainfall simulations on their predominant biosolids that's being applied to the St. John's basin, just to determine if there's any difference in terms of the potential for those biosolids material to become a source of phosphorus to the watershed. We are still in the analyzing the data, so none of this information has been published yet. Some we have summarized, so if you are interested, we published some of the preliminary results in the Cattlemen's magazine, but the scientific paper will be available soon.
And we are going towards the end of our interview today. I would like to thank you for participating in the podcast.
Sure, my pleasure.
And I am Joao Vendramini.
Joe what?